Okay, so it's time for some more RISC V graphics programming on the Serenum. So in the stream before last, we wrote a procedure that draws a disk directly to the screen by modifying pixels in a certain buffer on the Serenum. Last time we then began to translate this into like RISC V. Along the process, we found, after many attempts, a decent RISC V kind of emulator. One of the ones sort of didn't allow kind of like loop annotations. Another one didn't allow the common naming conventions for the registers. But I think this one here seemed to be the best. So in the meantime, since then, I realized that the instructions we wrote last time contained quite a few like arithmetic calculations, but also there was a bug in them, like they were wrong, and that I forgot to do the multiply everything by 4 operation by shifting all the bits by 2. But then this made me like realize that it probably would actually be better to simplify the logic here by doing something a bit different. I think in particular by breaking up this procedure into one that, by making this draw disk procedure call in the procedure call the assembly procedure, we could actually do this like pixel calculation first. We could also do some like bounds checks to make sure that any of the pixel modifying writes are not actually going to go into memory that hasn't been like allocated and cause like a runtime error. So the first thing I want to do today is to rewrite this so that it does do a very simple check that every pixel that gets drawn is going to be within the buffer. And then secondly, set up a different procedure called like draw disk assembly that will basically be the same logic here, except that this like pixel pointer calculation is going to get modified a bit. By modifying that pixel calculation, it means we can actually like skip the majority of these instructions and instead replace it with something that just adds on the frame width minus the radius each time. So we just need to, we can convert this into just two addition operations instead. Not that it would have that significant an impact on the performance anyway, since this code is only run once per the I loop. But like if you're drawing even like a small disk, it's an optimization that applies no matter what the scale is, so we may as well do it. Okay. Yep, so first up right now, I want to start modifying this in a sensible way. So the very first thing I think to do is to check that, we'll begin this with like a to-do. Check that every pixel that will get drawn doesn't like won't cause an out of bounds memory access. So kind of we'll figure this out, and then once we've done that, or we might actually do that a bit later, but we'll do it on this stream. I then want to replace this with the logic that doesn't require as many of these calculations. So I think we first want to calculate the pointer of like the top left pixel. So we could say we want top left pixel pixel. I don't know how people type using a QWERTY keyboard. It's infuriating. Top left pixel pointer is equal to, we want to do the frame.pixels, and then add to that a modified calculation here. So what we would want to do is update everything until we're like in the middle of the disk, and then we want to kind of step back. So the step back will be y minus the radius but it also feels a bit weird that this isn't like a greater than or equals to here. I think it should be that. So yeah, y minus radius times the width, and move all of that, multiply the result by 2. Yep. And then once we've got this, we can now set up this loop. But actually, since this loop is like iterating over these i's, we still want to like keep track of this, but we want to update this pixel pointer here. So now we want to, how do we want to say this? We want to say this is now the top left pixel pointer. And we've already actually, before we even do this, we need to adjust this prolata statement. At the end of every loop, in addition to increasing I by 1, we now want to increase the top left, we want to increase the pixel pointer as well. So I think in terms of like in some sense, like the assembly, once we've done this, we'll have to like call the assembly. For the moment, we'll just keep it all in one procedure, but once we've compiled this and it's working, we'll then like factor this out. So we'll pass in the top left pixel pointer into the assembly procedure. So we'll then want to just create a local variable to store that. So we can just call this here the pixel pointer, and we'll set this equal to the top left pixel pointer. And then, yeah, at the end of every loop, we want to increase the pixel pointer by the frame dot width minus the radius. You want to say frame dot width minus the radius. Okay. And then, okay, so in that sense we don't need to recalculate the pixel pointer here. Should be fine. And then within the J loop, we simply, what do we need to modify? This is what I mean by like kind of simplifying the code. Like instead of doing the arithmetic thing each time, we just call this once per outer loop. And then in the inner loop, we are likewise just increasing this. Now I'm slightly worried there may be some like off by one error in that like the lines that these things are getting drawn might be increasing in some weird way. Oh, there's also another error here in that we want to be multiplying both of these things here by 4. I guess I should really be casting these as well. In such a case, I guess this is a calculation. Again, we don't want to do an assembly when we can just like pass it in. So we could call that in up here. We could say like line next line increment, I suppose. Okay, so let's consider this like off by one error thing again. Okay, so say that we're drawing to like a 5 by 5 pixel array. Let's see what this is. And then let's say that like in addition we are we're drawing like a radius of 1. Then this disk is going to be like 3 by 3. It means if we have, let's say we're like on the middle line of this disk, and we have the pointer for the last pixel in the line, this is like pixel 4 out of 5, we then in the next line want to jump down to pixel 1. That is, we want to go down by 5 and then backtrack by 2. So in this case, I think we want to decrease the radius. Yeah, we want to decrease by like twice the radius and then like an extra 1. So I want to do okay, let's just make sure this scales. So say we were drawing like a 5 by 5 disk, and so the radius was 2. Then we would want to kind of move down and then backtrack by 4. Okay, which is likewise like twice the radius. Okay, I think this will work. which in that case would just be like the 5 minus the 4, which gives us the 1. Okay. So now we have that, which we can pass in. We can just completely replace this with the next line increment. Maybe just like the next line inc. We just want simple assembly. So then we call assembly procedure. So yeah, make a local copy of the pixel pointer we're going to be updating. Yeah, set temporary variable for I. Increase both I and the pixel pointer in this way. Make temporary for j. Increase j in the pixel pointer in that kind of way, and then another way to do that. Okay, let's try and oh no. I wasn't actually editing the disk source. It was in read-only mode. It's alright. We figured out all of the calculations, so we can just do it again. So calling the ASM here. This was minus the radius. And then we want to do next line increment, which was cast to a pointer frame dot width minus 2 times the radius multiplied by 2. Let's see, 2 brackets, yeah. And then, these are all in the incorrect places. Maybe let's just like use px for pixel. I don't know, it's more easier to understand like this. Okay. So let's try and compile this. So we want to go to the RISC V. We now want to do compile. Oh, it's not compile. The compiler has permission to search codecs for disk.obc, and then write the result to productor disk.pb. Oh yeah, at 32 instead of at n32. Okay, that at least compiled. Now let's see if it actually... Okay, it's still drawing the disks. They still look like disks to me. Yeah, I think this seems fine. So yeah, so now let's add in a procedure to the like assembly procedure. Okay, let's terminate that process. Okay. So how are we gonna do this? Let's like. This doesn't need to be a public procedure, so I think we can just call it procedure draw disk ASM, or we'll call it like pre-ASM. Maybe it's nicer to have it like this. Okay, so what here do we need to call things? We want to just call in the pixel pointer immediately. So we can just call this, it's an N32 pixel pointer. We then need to know the radius. We also, maybe it's more important to include like the next line increment. I would do that. I suppose this is also like an M32. Then the radius. And is that it? Oh, with the color, of course. radius is assigned 64, and the color is just an unsigned 32. I think this is all we need. So now we want to say draw disk pre-ASM, and we want to pass in the top left pixel pointer. Then the next line increment, which would be, I think, yeah, we can just refer to these as the same thing. The radius and then the color. I think we do need to have like a return statement, possibly, even if we're not or not. Actually, maybe not. Maybe we don't need it. Of course we will in the assembly, but otherwise might be fine. Okay, I think we can just compile this now and see what happens. Uh-oh. Yet again, I forgot to finish the procedure declaration with a comma. Always the way. Like, I forget the exact convention. Like, is it a comma when you're both calling the function and declaring it, or is it? For some reason, I think it didn't matter when we were calling it. But I guess we do. It's the same in both cases. No, top left pixel pointer it's confused about. Line 36. Oh yeah, it doesn't. Oops. Okay, that compiled. Let's check that it runs. as expected. Yep, I still see disks getting drawn. Great. Let's quit out of that. Okay, so now we truly can begin translating this assembly thing into RISC V. Okay. And yeah, already this is like simpler than what we were doing last time. There's now only like 4 arguments instead of 3. There's like the only multiplication now is with this. There's no like shifting needed. It's simple. Okay. So let's bring up our the code we did last time. We're gonna have to now like rewrite this, but now that last time we found that this like Venus, what is this, what it's called? This like Venus emulator is actually decent in that you can use like the common register name conventions like A0 and A1, and it won't actually panic, which the other the other assembler couldn't even do that. So I think actually the best thing to do is just start afresh. So let's say like as for the sake of example, we're doing like draw disk ASM. Yeah, like top left pixel pointer. Next line increment the radius and the color. When we're needing this, we want actually, does this allow load immediate? Let's see if we wanted to load one, let's make it like 111 into register A0. Does it work? Perhaps not. In either case. So for the sake of example, let's just pretend that we're doing this with top left pixel point is 0. Say we do want to do this this like 5x5 example with like a radius of 1. What we want to see is like this kind of disk getting drawn. So we'll start off at 0. Well, yeah, that's fine. We're starting with 0. The next line increment should be 5 minus 2, which is 3. The radius here is 1, and in terms of the color, let's make this like, we want to make this something we can see in the memory of this Venus emulator. So what would be something easy to see here? I guess like CCC, or like, no, we'll do Andrew Kelly's thing. We'll call it like AA. From memory in this like RISC V spec, it's like really like if you want to load some intermediate, you have to like load like the lower part and the upper part or something silly. So we might actually just keep it as like AAA for the moment. It would be good to see if even the emulator can deal with this. It's out of range. This is a quality error message. this is not what the other emulator was giving us at all. Okay, and it can deal with that. Like, it wouldn't be too hard to actually get in what we wanted, like the AAA thing, without doing some weird, like, without having to look up this, like, load upper, load lower half. If we just do, like, a logical left shift intermediate of A0, but now with, say, 8 bytes, and then we likewise add to A0 2 of these. Oh, what? What's happening? Oh, LLSI not found? What is it? We want, like, left shift logical immediate. Oh, it's SLLI. Shift. Why does it expect that many arguments? Oh, because we still need to specify where to put it. Okay, SLLI. Shifting A0 and storing it there. Okay, so if I check out the registers in A0, which is X10, yeah, we now have, like, A's. Great. So we may as well just continue to do this for the sake of example. If we just repeat this, it'll be fine. Okay, and then this is just for us. This is just saying that A0 is equal to and then except we want to be storing this in A3 instead. Okay, the top left pixel pointer though is just 0. Then the next line increment is a 3 in this case. The radius is 1. Okay. Yeah, we know what that does. So the above is just for this example. So now we've got that, we can begin to translate our assembly. So we want to we need to have some, like, temporary variables. The pixel pointer I and j. So let's say yeah, we want to let's store oh, why is my capture card failed? What? Okay. That was so weird. So weird. Apparently, just reading in a HDMI cable and putting it to a buffer is too difficult for some hardware. I really hope Framework makes like a capture card in the future. That would be dope. Yeah, so we want to set T0 to be negative the radius. So we can actually do like subtract from x0 the radius, which is a2. So I want to say T0 is equal to negative radius. Or T0, which is I, is equal to the negative radius. We then, and there's, wait, I'm now forgetting why we're having like I is equal to the radius instead of I is less than or equal to the radius. Because like in this disk case, if the radius is 1, there's 3 lines we want to draw. So it should be like I equals -1, I equals 0, and I equals 1. Maybe I just we didn't pick that up visually from the things. In either case. Like, is there even any need to call this loop I? Yeah, we should. Well, no, we have to set that, and then we have to do like the setup. Let's call this init. Well, there's like the example that we're doing, and then the actual init. We continue this, and then we have the loop I. But once we've set T0, we don't yet set T. Is there any point actually setting J here? I think it's like safe if we just because like we made this bug last time where we like forgot to reset things. So we'll just like kind of like reserve J, or like T1 will hold J. So we want to set T2 to hold the pixel pointer. As I'm saying this, I feel like it's easier just to think of T1 as being I and T2 as being J, and in fact T0 as being the pixel pointer. So we'll make the pixel pointer that T0 equals pointer, and I should actually have this like as some comment as well. T0, T1 is equal to the pixel pointer I and J. No need for this then. Okay, with that done, we can begin to write this loop. So let's also just align this. So at the end of each, so we're going to do like the loop logic, but at the end of the loop we want to add 1 to T1 and then increase the pixel pointer by the next line increment. next line increment is being held in A1. This is just a normal add. Okay, and then we want to then check to see if we've reached the end of the I loop. Something we failed to do at some stage last time. So we want to have this kind of logic. Break if not equal something. So how do we do this? Let's also annotate what's happening here. That looks a bit weird. So yeah, loop if I, we want to loop if I is, if I is less than or equal to the radius. So we want to do branch if greater. So we have, yeah, branch is less than or branch is greater than or equal. So we have less than or greater than or equal to work with. Last time we had to do this like logical calc thing. It was annoying. So let's see. So we want to say jump up and branch. The very final thing over here should be return. But we want to first jump up to, we want to jump back if what? So I think the way to express this is to say, like, yeah, we need to, an equivalent version of this is like a continue if I is greater than the radius. Or in other words, jump loop if, we have to like express this in terms of the radius. So currently we're saying, yeah, branch if the radius is like loop if the, can we say loop if the radius is greater than, if the radius is greater than I, greater than or equal to I. Yeah, branch greater than or equal to, yeah. So yeah, provided the radius is greater than or equal to I, that means like I hasn't yet like exceeded it. And then as soon as I exceeds it, it's not going to be larger than that. So we want to say loop if the radius is greater than or equal to I. So you want to say branch if, was it BGE? Branch if the radius is greater than or equal to I. The radius is being held in A2, I is being held in T1, and we want to loop back to loop I. Okay. And then if that's all fine, we then return. Oh yeah, I have to use like SD and other stuff. Okay, so let's do like the loop body of the I now. So I think nothing really actually happens. Like the loop I is just calling like the loop J, and that's kind of it. Well, well, no, we have to, each time we're in the I loop, we need to set up the J. So we want to say a T, first of all, like 0, whatever's in there. We failed to do that last time. Not even just 0 it, like, what is J? J is set to the negative radius, so we likewise in here, there's a bug, I think. Should be like equal to the radius. We want to subtract from 0 the radius, and set J to be that. J is equal to negative radius. And then we need to do the loop J. These should be indented. So likewise, we'll fill in like the loop logic, but at the end of this, we need to increase J by 1. Then we need to increase the pixel pointer by 4. And then, since at the end of this, we're going to be jumping back to the we're going to be jumping, we need to decide whether to exit the J loop or not. And so the calculation is just basically the same as we did for the I. So we're going to loop if the radius is greater than or equal to J, but since we're dealing with J, we want a T2 here instead. And then, yeah, we call this like loop JN. Since we have an if condition, we're going to have to loop JN. Okay, so let's say we enter this like loop J. We need to do this disk calculation. So just I squared plus J squared and compare that to radius thing squared. So what are the registers we have to work with again? Where's the list? Not here, here. We have T3 all the way up to T6 as well. So let's store like T... yeah, we'll say T3 is equal to, well, T3, T4, T5 is equal to like I squared, J squared, and then the radius squared. Now typically, like, since the radius squared isn't actually being changed at all, we can just calculate this once at like the very top. So we could say, we can just say multiply the radius with itself. The radius is in A2 from memory. And store it in, and leave it in T5. Okay. And then back to here. So we want, if we want to set T3 to be I squared, we need to set, I guess we can just say multiply I squared and send it to there. Likewise, multiply J squared and send it there. And then we want to add these two together. And then we want to do our like compare, and if the comparison is like successful, write in some colors. Otherwise, jump to this loop end. Okay. This is like I'm way more comfortable than this than last time. Like having just to like use the X's everywhere was ridiculous. Okay, so how do we do this compare? So we now want to do another branch. We want to jump to loop end. Jump to loop J if I squared plus J squared is greater than the radius squared. We can do branch if greater than. Right. No. We can do branch if less than, or branch if greater than or equal to. Less than or greater than or equal to. So we want to branch if the radius squared is less than this thing. If radius squared is less than I squared plus J squared, that is the distances. The pixel distance has exceeded the radius. So yeah, branch if less than well, branch if the radius squared, which we stored in T5, is less than, this is correct, right? Yeah, is less than what we just stored in T3, and jump to loop J end in this case. I just call this like loop J end. Loop J, just so everything continues to be aligned. But otherwise, we need to save stuff. So we now need to do the color writing. So you want to say pixel pointer is equal to the color. So now we need to like think about how to deal with this in the in this particular emulator. So presumably we can do like SW for write word. Write word, what's the convention? Store word, the value and then the thing. So the value here is the color, which was A3, and then so using this convention. And then we just want like the pixel pointer, which is T0. Okay, I think that's it. Let's test it out. Could not find loop label JE line 28. Sure. X used, but what? Line S2. What's going on here? Yeah. Line 17. Oh, it's just meant to be an add here. Okay, that compiled. Let's clear this out and save it. And now let's see if this works as we expected. So when we run it, it will exit with this. Oh, instruction not found for oops. Yeah, I guess we will only let's just store like a couple of these. Like, why is this causing an issue? Why are all of these invalid instructions? Like what? Okay, we're just dealing with like the basic BAA. Okay. Now when we run this, structure not found for 0, 0. What? Okay, let's just step through this. So yeah, what are we? So we're setting pixel pointer 0, line step 3, radius 1, color AA. Okay. So we set all of these things. So now we've got the setup. Those are the values we want. 0, 3, 1, and A. And then we need to do the loop body. So yeah, so now we're like initializing everything in the temporary registers. So yeah, T1, which is I, which is -1, which is the radius, is fine. T2 is that, and then we want temporary 5 to be the radius squared, which is 1. That's fine. Now we're saying add add the squares together, which gives us 2. Branch if 2 is greater than the radius squared, which it is. So we should immediately be doing the j increment now. Yeah, j plus 1, increase pixel pointer by 4, and then we want to loop again. And we're jumping -28, which 3C, that looks, yeah, 12 plus 16 is 28, that's fine. So yeah, oh, why are we like jumping to I squared and j squared again? This feels like an optimization we could make. We're not actually multiplying I squared by itself every time. So we can actually we can factor this out. No need to do that every time. This here though, at the moment this is going to give us the same bug that happened last time, which is that T3 grows absurdly high. I think, well, it's fine. Like we're resetting I to be this anyway, and I'm adding that. Okay, it should still be fine. Yeah, do this. Let's just reset. So yeah, so the very first one we do shouldn't be writing anything. So we should just branch which we did. The second, basically everything, like no write should be happening on the first line, so we should skip this multiple times. And now we should skip it 3 times. And then no, this isn't. It should be skip, write, skip, write, 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 skip, write, skip. So what just happened? So the very first time there's not going to be a write, but I am expecting a write this time. Why is the sum 2 here instead of 1? After all, we should be getting -1 squared plus 0 squared is 1. Why is T5 not? And why is T3? Yeah, what's happening here? So J here should be 0, which it is. And then here we want to be updating T4 to be 0, which it is. And now when we add T4 and T3, we should be getting 1. What's T3? Oh, so why is, oh, I see. Yeah, I get it. So this was like a consequence of me factoring out this I instead of resetting it every time. Given we have to reset it, we need to have an instruction to reset it anyway. Well, you reset it or store it in a different, or store the sum somewhere differently. No, I don't like this. I feel it's easier just to like calculate. Like we need to do a J squared calculation each time, and then we need to do a sum calculation each time. If we do the sum by adding it to the I squared, we need to reset it, and we do a sum, which is like an extra instruction. Alternatively, we can just add the I squared to the J instead. Let's do that instead. So let's do the J squared, and then we want to add to the J squared the I squared. Let's just start. then here we want to be doing jump if this t4 is less than that. Okay, I think this should be fine. Let's give it a go. So the very first time no write happens, we do want to write this time, and it does. Then we want no write, and likewise we like increment the line pointer. Now we want 3 writes. Yeah, 1, 2, 3. Now we want no write, great, and then a write, good, and then oh, now it's suddenly, before we even get to do the final write, we get invalid instruction. Make sure you're not jumping to the middle of an instruction. What? Okay. But otherwise things seem to be going correctly, unless like the memory is failing massively in some way. In either case, we should be able to like watch the memory update here. So we step through this. Yeah, so A has been written here, which is good. Then we want to see like all of these ones here should become A's. And like the oh, why is the A getting written here? That's not aligned. Did we forget when we incremented things? Did we forget to like multiply things by 4? Yeah. Yeah. We're not actually adding by 3 here. What we really want to be doing is adding by 4. Did we remember to do this in here? Yeah, we have next line increment multiply by 4, so that's fine. It was just here there was an error. Okay. So this means we just want to be multiplying that by 12 instead. So yeah, we do all of this. Yeah, the first A's been written. And then, yeah, we've got the stuff here, which is fine. And then, why do we end up here at invalid instruction? Like, where did this come from? Oh, it's because like we're actually this is like not actually an issue. This is just a simulated issue. The oh, this is super embarrassing. All of this data here is actually the it's actually the machine code of our program. So we want to go to an area of memory for which this is not an issue. Where we're not writing. So let's like just start at, you know, memory address 256. Okay. Okay. So now we should be seeing A written there, and there. Yeah, great. Let's just run the entire thing. Oh, it's like infinite looping. No, didn't want an infinite loop, I think. Why isn't it? Like, okay, it seemed to be working. I just don't know why it didn't exit. Which is a problem to catch here instead of on the Serenum. Why is there such a big gap between these? Why are we not? Something seems wrong. First write skip, increase stuff, and now for the next write. Oh, hang on. We're working in like the 5 by 5 pixel buffer, so this is actually working correctly. Like the row of pixels is from here to here. So then the next row is from here to. Wait, no, that seems incorrect. So it's from. What? So yeah, the top left is here, which means the actual line starts here. So why are we not seeing that one? In either case, what's I at this stage? I was T1. What's T1? It's 1, okay. Okay, and then we should be leaving the loop here. I mean, not branching. So yeah, go to the next one. I should now be, 2. And then here we should be returning. Which we do, okay. Okay, and now it's just, the thing itself is just, I feel like in the Serenum this is going to do what it's meant to, and not actually, use the function pointers and everything. It's just using like standard calling conventions. Okay, so the issue that I see it now is just that these bytes seem to be getting written in the wrong place. How do we fix this? So the claims I'm saying the top left is here. So if the line starts here, then yeah, why isn't it? Oh, actually it is fine, I was just not counting. hang on. Here, like empty, empty, pixel, empty, empty, new line. Yeah, it should be here. What's going on? There's an off by one error in like the amount we're jumping down by. So I'm saying jump but down, jump by 12, but it should actually be like 4 bytes less. What? Yeah, it should just be 2 times the, 2 times the radius. That was silly. But let's just check, it is 2 times the radius in here. Right. Yeah, we've got it in there. Okay. No. Why is this not writing in the correct place again? Because we, what? Did I not save this? I copy it? Yeah, okay, this is working as intended now. Okay. All right, so let's save this. Yeah, like a sketch of the, well, like it's not really, yeah, it is a sketch of the RISC V assembly needed to implement draw disk ASM on the Serenum 6. Tested using the meant to simulate the following pixels. Let's see. Okay. Alright, maybe we should like copy this. Okay. Okay, so now we need to get this into the Serenum. And then I'm just gonna pray that there are no other issues. Let me test it for real. Okay. So swapping keywords. So there was, like, in this programming language, there is a way of declaring that we're going to be doing an assembly procedure. How is it? Okay, it seems just to be a single quote, and then things are tabbed. So let's do that. Just tab, quotation marks. And then we want to copy in this. Would it be worth actually like dealing with the Windows transfer process and like just saving this? I don't think so. I feel like it would actually be quicker just to type it out again. Yeah, we'll just do this. Okay. Toggle full screen mode. Yeah, so we want to do init. It would be good just to annotate what everything is. T0, T1, T2 is equal to pointer I, J. That's kind of it. Then we're subtracting T1 x0 2 and multiplying into T5. And here we want like double word. So we want to do so here we need to yeah, the color, and it's in just T0. Then our loop J end is to add to increase that by 1. Increase the pixel pointer by 4. And branch if the radius is greater than greater than J. Otherwise, increase I by 1. Then increase the function pointer by the distance. And branch if the radius is greater than that, otherwise return. Okay, let's a moment of truth. Let's see if this compiles and renders in the way we expect. So let's see, this is called draw disk ASM, and we're calling that up here. All right. I am a bit scared. This is not going to work. But we tested it. Oh damn. Why? What? But I've set queries with a corpus residual. How do we do this? We need to say procedure compilator. Okay, that at least seems to have compiled. Will we get a runtime crash? And if not, will we get disks being drawn correctly? Moment of truth. No runtime crash. Okay, but we're not exactly drawing disks here. We're drawing ellipses, but this is good. This means it's like a logical error instead of something else. Okay, how do we? And curiously, these are like, we're not getting these drawn like diagonally anymore. interesting. Okay, first of all, how are we going to correct this? But this is already great. Like we're drawing this in assembly in RISC V. And it's almost working. Let's quit out of this. Yeah, what's the error? I mean, we're not going to be modifying the assembly anymore. I think we can fix it just by this. I know. It's because when we're like technically when we're like on the pixel, say this is like the 5 by 5 case again. Technically we want to go back like 2 pixels, but at the end of the loop it gets updated by 1. So we actually want to subtract like an extra 1 to account for that. Okay. I did save that, didn't I? Potentially not. Save. Suspend process. And then let's compile. And also too, the ellipses were like being stretched to the right, which meant that we weren't going backwards enough. So I think just subtracting 1 should do the trick. Haha, great! This is incredible. We're drawing graphics just using RISC V assembly. Fantastic. Very different, so different to graphics today where you have to write 1200 lines of Vulkan just to draw a rainbow triangle. Okay, this is promising. So now I want to get this so they're not like just being drawn in boring lines or doing something with these. But this actually raises a question, like why are they getting drawn in this way instead of as before? For instance, there's going to be another bug here if when I swap draw disk ASM with draw disk like a pre-ASM, things look different. So I don't think this, I would be really surprised if this comes out differently. Yeah, what's going on? Why is this like draw this pre-SM like Like what? Does it have to do with like the way we're like returning from the procedures? This is very troubling. It may be because we're... Oh, I know why. It's because we're stomping... I think we're like stomping values in... Like it has to be because we're like stomping some register values which are holding information in the stuff that's calling like the draw disk. But what exactly is that we're modifying? We're just saying draw disks in a bunch of like X and Y positions with various colors. Like we need to look at this calling convention again. Okay, here's the stuff. This like Corley and Corley are like the worst names ever. Like, how is anyone meant to like remember which is which? It's so ridiculous. So I guess like the caller means it's so bad. No one ever knows. Let's just use the LRM. Actually, Corley versus. Like, what's the one, like, if function A is a calling function B, which one is the coolie and which one is the call A? Like, the Rust user groups to the rescue. No, the Rust was not helpful. This looks like an SEO optimized thing. Well, okay, when function A calls function B is the callee. Okay. So, yeah, the return address is like saved by draw disk, and then the ASM is meant to be saving a bunch of things. Okay. Oh, well. We're not using any of the saved registers though, so it like what are we stomping? Are we like forgetting to like save the stack pointer in some way? This shouldn't. What are we forgetting to do? Modify. And we can do li in this code. Yeah. So here it may be good to just look up in the standard library what's happening with the draw rectangle procedure. Yeah, it's unclear to me from this alone and what we've done what's failing. Like we only use temporary register that the caller is itself meant to save, and yeah, we're modifying the function arguments and return values, but the caller is saving that. So yeah, what's the issue? I don't know. Yeah, let's check this out. But otherwise, we might end the stream soon. Okay, so this procedure stuff was in the. It was in like we spent a while last time finding where it was, but this was in the like basis arena. Scripter. Yeah. Yeah, I don't see anything special this is doing right here. Could it be what's happening when we're passing, oh, yeah, it could be what's happening when we're passing in the arguments in some way. Oh yeah, if we're doing these, like if there's a difference in these instructions between like add signed and like all of this stuff, then that would be screwing these up. So yeah, like it doesn't, hopefully it's not any calling convention thing. Okay, in either case, so yeah, interestingly, everything here is just, nothing here is signed. Everything's just being converted to unsigned, and in particular unsigned 64. Probably wouldn't be a bad idea to do that in our case. But even then, like yeah, I suspect this is up. Yeah, everything is signed. Okay. Let us modify things accordingly. Let me do script or edit. Add a disk. So yeah, let's say we made the radius. Oh, but this is the thing though, where like we are counting on this to be signed. And it was like the -1 was showing up when we were doing everything in the emulator. So I guess the only thing it can be that's like drawing the disk in the wrong positions is this TL pixel pointer. So for whatever reason, when we're like calling that in the assembly version, things are getting drawn in the wrong place, but in the other version it's fine. If we do the CLB again here. So like visually, what is this telling us? It's saying that like horizontally, the horizontal ones are failing in some way. It may just be good to remember what these are. So the magenta here is just going left, the cyan is going right, and then like the gradient of the yellow is like -3 or something. What happens when we, so yeah, magenta, cyan, yellow. What happens when we, come on, this has to load. Come on, Serenum, you can do this. It's rather, are you serious? You mean no signal, of course. Do I have to pull the plug? I think I do. Why is this not working? Like Elgato is so bad. Like when it comes to doing like another capture card, I'm not getting it again. There's been loads of times where I've like booted it up and then like it just refuses to recognize it as well. Let's try it again. Okay. Maybe it's gonna work. I guess maybe this is like the end of the stream then. Like, this bloody, should I just like relaunch it again? It's already running. Interesting. Where's like the simple version? Oh, okay, there it is. Hopefully that's it. Can even end it. so painful. Okay, it's working again. Fine. Okay. So we wanted to see what it looked like when it was working correctly. So we go into the RISC V drawing experiments and particular into the codecs and check out, we'll really edit the disk libc. Then what's time to do here? I feel like at this stage I can like delete the majority of things. Like I don't want to like vectorize this. That feels like too much at this stage. The purpose of this exercise was just to give us some practice with dealing with RISC V on the assembly. Delete that. Delete this as well. Now we'll open this up. Product disk. Oh, I guess we need to. So this is what it is before. We want to compile the new version. Yeah, I'm confused as to what's happening. Okay, so like the yellow doesn't seem to be affected that much, except that in the previous version we were also getting like outlines, like you could actually see like a black disk getting drawn, which is interesting. And then yeah, here the purple is still going to the left and the cyan is going to the right. So are we returning from like one of the loops, like prematurely in some way? I'm not sure. I might like ask the Discord and see what's happening. Yeah, I am lost. Like, yeah, like, why is the... I mean, I have two questions. Like, why is the YPOS information getting lost? And then, why is... Question one and number one. And then, why do we actually see these, like, these outlines of the disk? Wait, we should be, like, compiling, like... Why do I keep on going back and compiling these things? We should compile, like, the pre-ASM version and then, like, the ASM version. So, okay, so we'll compile the ASM version here. So let's make a file in the productor called disk asm.pb, and then now we want to, oh, it's being converted to lowercase. CLB codecs disk.lvc, and then we're writing this to productor disk ASM. Now we can just switch back and forth between them, take screen captures, and other stuff. But yeah, I might have to ask, I think I'm going to have to ask the Discord what's going on. Yeah, it's like the... Yeah, what could be happening? Why are these... Okay, let's like record captures of these and then so I can ask the Discord. Actually, let's just like get this running. Okay, so that's good, and then we want to save this in Serenum ASM. And I think that's kind of all we need. Since last we kind of know what it. It may just be good to like get this one too. Well, we know what this was doing last time. Yeah, let's just save what we've done physically, and then I'll end the stream and we'll troubleshoot this later. Well, I'll let the Discord help out. Okay. Okay, so I'll pull the power on the Serenum. Get rid of this. Let's make a backup so I can share the source, which I have to share the source anyway. Okay. Now using the Serenum and my extract the memory card and back this up. I might need another port. All right. Why do I bother? Why do I bother? Do you want Serenum backups? And what? Serenum 6, 2014. Oh, and today is like the first day of September, I think. Yeah. We'll copy that into here. Yeah, let's find where this stuff is saved. Yeah, search everything, and we want to look for like disk ASM. Drawing experiments 2.7. Great, and here it all is. Okay, so yeah, I'm gonna ask the Discord for advice as to what's going on. Get rid of this one, I think. But otherwise, thanks everyone who dropped around to the stream. And yeah, I'll see you later.